Sikole ngambulo luku. With whatever we do. Jioni safu no la. With whatever we do. Hale yide munyu skula. Nyepamne ne kudlukula. Nyepangi ragala gena. Nyepamne ne kudlukula. Ibuloke no moto ni beti sola. Ibuloke dato ni betoto.
Mingi Congo.
Lamin.
Na?
Lamin te jibe norin te nyamen Lamin.
Kabana wulo kono.
Wulo kono nyin tay mo Lamin.
Pabilenki.
Muna ngata afamole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyole.
Ngoto le Fabrama.
Namu jumara kan kuma diten.
Fabrama.
Jumara mu.
Ndele bare muso.
Lunda mana.
Amokata.
Jamani mbere.
Alindo ko.
Jamani.
Bari ngoto man kontande.
Bari jamani fana na mundu wa kontan.
Ngoto minaka ngalamin je fom filitala. Lamin jibe nori nyala.
Lamin ida siram sama ne benki. Yala so tol sayni no ko mo la ko momo.
Ngoto.
Nam.
Itedinte yalo ne Lamin hakilo diata bake karamngoto. Anu sainteng ministry ko di ngole si suoko na amanke ko do holiday
si bitun
Bagona de
ala ni ko kede namo balo
ala ni na ko ina karta bulo be dam ala ni je
ngoto
nam
ngoto mon kontan fere
jamani mu nekata
ifika Lamin ki wulo ko no nyintai mon ko do fete malo Lamin nyanta sila la be la moy kala karango
jamani karamol be sorande ne ko fasita wulo ko nako
karambo wol ma soron ni ko karambo wol soron da amanke ko holiday dindi ngo nyanta sila la ala karango la moy yamen kamen fue man kontaan anda mande
alla nyin kombo courant adanda la kombo len do la jankara mol soronda do kamen courant ma ara do la kombo e ko ndol fana na kara mol soronda e kara mol soron Lamin ada lo nyino la amanta ra fena sokon ala munekela
am Lamin ite foyde malon ko lesinol be ke kar radio to
nga fine
e ko yana di mod Lamin
nga fine
ya muna fonye
bir kabin mina kan tambita nteri maning Fatu tambite la sukol ala dinngol bebe siri be la moy ka
Faru danso am fana tambita jele ni subala la ngaje dinngol be je talanta nin kili warol e be seri jele
sa Lamin fadante ku kili wo ke no la ba Lamin bitaka wulo ko no nyin taymo Lamin
amanda ra fenela
ite dine ko ni man si yakari lesuno la moy radio to e balon na
muneka ke afonje ba nyara ni alon
telentel jikot
afonje ba mu be ke
ite balon tel be jikritel ni man karambe ku kele yaje nata karana mbasa malaya e tarije
par ñarande kombo courant ho findira kombo ide nara yede ni sonka bay ko Lamin mañana tala wulo ko adu karam mo be so da fa ñembe kala
ko to wole nati ba ngalle ni tal kombo courant o ka fa me kombo courant asototal wala kinay ko e si suwo kono bari ni ko e si suwo kono be karangol di ke la radio lin telel to hani tele masoto to nyaay man tele soto la bongo bar radio be bulan koto batiri sanga ay si ay alamo
sa do kala nyaadi
ko ta o bulaji
abe o kala nyaadi
kamun ke nyaadi
radio abe wala moy la ibe mona falaje
ibe la karandirol kala jele
ti tale be radio ko men ga karandirol
ila subject ro baby jele baby jele
wala nanga coco moy fa dan so wolya ngombe tambi kana ngadi ni wolje be ikadum bungo de ko kada
ma asototal de
Lamin mala be karawala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko di
sini lamba ndele sini lo ne ba
mbasa mba foke en koto wole fango yen wulindi yalo famo keta bat yu fana bulata ko ko me yen nati jambi Lamin nyanta karana ndel be jiko be nyineka ya bula kara wulo kono ta kilar ya bambalo yo be bula je koto dindi ngoy si ayala le sino la moy radio
wada ka munda kara mo man soro Lamin nyanta kara si so na
radio la sila le ayala le sino
dal ko korno ko smalo
kilar ya
be ngala ko momo sa mi do ni ko no kera
mengi bruso
ndelo ko do la ba rosa no radio ba no bari woro radio ni abe je le ba do ngamro do man dembe buljan dala nyala nyar wo ko fendi mo la Lamin tawra ba rosa
bara te ku folo ajibe nori nya labi tamete ku
teku
bari ko do famo ke
imagine nañu ñambol si zol le keje kisigi man si zol no le ka ñambu kino li mañana ka finde ni nambe ko zol la ga
ngalle limbeta de be ñambo do dilanna
ñara ni ko rim fennat ñara nata
ko bari famo ke da
ngata bun kono tabi bun kono ñara ngando ko fele ko ke baru nganda ni pelo la ndija
iyo awe better la
bun kono bismillah bisu diara
ye fongo tanka sina dolu tanka koro ta koro
Hello, viewers and listeners. Good day and welcome back. I'm your usual presenter, Mr. Ibrahim Ajadama, and I usually present on science. And today we are going to look at a topic that is called electrolysis. Electrolysis. Good. So from this topic today, we are going to look at the definition of electrolysis, and also we are going to be discussing some important concepts on or about electrolysis. Definition first, and then also look at some other important concepts on electrolysis. Good. So now before you go into the definition given to us from the note, let's try to brainstorm by ourselves and look at how to define this term, electrolysis, or let's try to break it down into pieces for our understanding. I'm pretty much sure that you are always familiar with this term, lysis. You see this word always in certain words, attached to certain words, lysis. Just like, for example, hydrolysis. These are terms I know you must have heard of. You must have heard of the term glycolysis. So what does these terms mean to you always when you hear or see the word lysis attached to a term? Good. Lysis simply means breakdown or to split, to decompose. All this can be applied there to break down a substance or a molecule, to split, to decompose. So now let's look at this word here now, electrolysis. Two words there, electro, and already now you know what is lysis. We said their lysis mean what? Either to break down, or to split, or to decompose. What about electro? What comes to your mind when you see or hear this word, electro? It's very simple to guess. It's what? Electricity. So here, if electro here stands for electricity, and lysis stands to break down, or to decompose, or to split. So what does the term in full mean now? It means using electricity to break down. Using electricity to break down a substance or a molecule. So we say electrolysis, please. I hope that will give you a little bit of understanding about the term. So let's look at the definition there proper from the note. What is electrolysis? Electrolysis is the decomposition of a compound, molten or in solution, by means of passing an electric current through it. That is the electricity, please. So I repeat that quickly. We say electrolysis is the decomposition of a compound. Decomposition there means to break down or to split, please. Of a compound, the compound can be molten or in a solution by means of passing electric current through it. That process is what is called as electrolysis, please. So take note of the definition of electrolysis from now on, please. All right. Compounds which undergo electrolysis, either fused, that is, or molten, or in solution, are called what? Electrolytes. Substance or compounds which undergo electrolysis, either in a fused state or molten state or in a solution, we call this substance as electrolytes. An example of electrolyte will be what? A salt solution will be an electrolyte. Salt solution is an electrolyte simply because it can allow electricity to pass through it, and in the process, the salt will be decomposed, please. So these substances, we call them electrolytes. Compounds which do not undergo electrolysis are called non-electrolytes. Non-electrolytes. Compounds that do not undergo electrolysis. Example here will be what? Let's say sugar solution, or sugar in short, or let's say ethanol or alcohol. These substances or compounds are non-electrolytes. Why? Because they do not undergo electrolysis, simply because they do not allow electricity to pass through them in order to decompose them or to break them down. So we just call them non-electrolytes. Please take note of that as well. We said there, the waters in the rivers, seas, and lakes, as well as the water from a tap, conducts electricity because it contains dissolved solids. This means that it can be dangerous to handle electrical appliances with wet hands. Please, I go over that quickly. The waters in the rivers, seas, and lakes, as well as the water from a tap, conducts electricity. Why do they conduct electricity? Because they contain some dissolved solids. Most of these dissolved solids are conductors. They can allow electricity to pass through them. So when they are in solution in the water, that water can be able to also conduct electric current. So this is why we say there, it can be dangerous to handle electrical appliances with wet hands, please. Okay, let's move. Still electrolysis. We say there, electrolytes do not just let electricity pass through them. Something happens in each solution as well. Sometimes bubbles of gas can be seen at one or both electrodes, and sometimes a solid or a liquid appears around an electrode. New substances are obviously being formed. Let me go over that as well. Electrolytes do not just let electricity pass through them. Something happens in each solution as well. Sometimes bubbles of gas can be seen at one or both electrodes. In the apparatus used for electrolysis of a substance, there are certain parts there called electrodes, as you can see. This is an electrode, this is an electrode. So this solution here is the electrolyte. It's the electrolyte conducting the electric current. So when you are electrolyzing this particular compound here, what happened? Sometimes bubbles of gas can be seen around these electrodes, sometimes. And sometimes also, a solid or a liquid appears around an electrode. At times not a gas, but at times it can be a liquid or a solid that you may see around the electrode. That is showing that something is happening. New substances are being formed. That is to say that the electrolyte is being broken down or split or decomposed to produce new substances. I hope that is clear. We say again there, electrolytes let electricity pass through them and at the same time are chemically changed by it. Electrolytes let electricity pass through them, and at the same time are chemically changed by it. This kind of chemical reaction is called electrolysis, a reaction in which electricity passes through an electrolyte and causes it to decompose or break down. That term is called electrolysis, as we just explained, please. So you are seeing it there again. Electrolysis is the breaking down of a compound by electricity in short. Very simple definition. Electrolysis is the breaking down of a compound by electricity, please. Never forget that. Still electrolytes. For some electrolytes, the new substances formed at the electrodes come from the dissolved solid. Example, the copper and the chlorine formed from the electrolysis of copper chloride solution must come from the copper chloride itself. Good. Let me repeat that there. For some electrolytes, the new substances formed at the electrodes come from the dissolved solid. I say example, the copper and the chlorine formed from the electrolysis of copper chloride solution must come from the copper itself. If you are electrolyzing a solution of copper chloride, which is just CuCl2. Here what will happen? Sometimes this chlorine, the copper, as you know, is a positive ion. The chlorine is a negative ion. This copper and the chlorine at times will come from this solution itself, the copper chloride itself, directly from itself. The copper that will produce at one anode and the chlorine that will produce at another anode will come from the copper chloride solution itself. But we say there again, but the electrolysis of some solutions give hydrogen at the cathode and oxygen at the anode. For some electrolytes, when you electrolyze them, what will happen? They will produce hydrogen gas and oxygen gas. Hydrogen gas will be produced at the what? At the cathode, rather, the negative electrode, while oxygen will be produced at the anode, which is the positive electrode. This is what happened for some compounds. Even though the solid dissolved in water might contain only one of these two elements or neither of them, even though the solid you dissolve as electrolyte might contain only one of these elements or sometimes neither of them. Why does this happen? In this case, the electricity must be breaking down the water in its elements. When you see this happening, you should know that the electricity is instead breaking down the water into its elements. As you already know, water consists of hydrogen and oxygen. So it means now this water is being split into hydrogen ion and oxygen ion. Please. I hope that is understood as well. So we can proceed. Now, electrolysis, the apparatus. The apparatus we use for the process of electrolysis, please. So you are seeing a simple demonstration of the diagram here, please. The diagrams can come in different forms, so you have to understand that. But what you have to understand is the basic parts of the diagram in terms of the electrodes, the anode and the cathode, and also the DC supply, that's the cell or the battery, and some other important things there. But the diagram can be in any form, please, so don't be confused with that. All right, so in the apparatus, during the electrolysis of the solution, what happened? The terminals through which the electric current enters and leaves the electrolyte are called electrodes. The terminals through which the electric current enters and leaves the electrolyte are called electrodes, please. So you are seeing two electrodes in this diagram here, please. This is an electrode, this is an electrode. So it is through these electrodes that the current enters and leaves the electrolyte. How does the current enter the electrolyte? It starts from the what? The negative terminal of the battery. So you can see the flow of current, as you see the arrow now, the flow of electron flow, please. So current enters through the electrolyte through the negative terminal, that's the cathode, and leaves through the anode, that's the positive terminal, please. All right. So the electrode connected to the positive terminal of the battery is called the anode, please. The positive side is called the anode. The positive, as you see, are seen here, anode. The positive electrode is called anode. The electrode connected to the negative terminal of the battery is called the cathode. The electrode connected to the negative terminal of the battery, negative, this is negative terminal of the battery, this part. So this electrode is called a cathode. And electricity or electric current enters through the electrolyte, into the electrolyte through the cathode, and leaves through the anode, the positive electrode, please. I hope that those parts are also understood. Okay. Still about electrolysis. All electrolytes contain ions. Another very important concept on electrolysis. All electrolytes contain ions. And what are ions? You'll get to know that very soon. So we say all electrolytes contain ions, which are electrically charged particles formed from an atom or a group of atoms. By what? By the gain or loss of electrons. Just as you see the example there, copper can lose an electron or two electrons to what? To become a what? A copper atom. Copper atom. So this is a copper, sorry, not copper atom, rather, but ion. Copper plus, 2 plus. Okay? All right. So this is copper atom. This is a copper atom. It will lose 2 electrons and become an ion. That is copper ion. And what is an ion? As you see from there, ions are electrically charged particles formed from an atom or a group of atoms by the gain or loss of electrons. When an atom loses electron, it becomes a what? A cation. when an atom gains electron, it becomes a what? An anion. We will learn all this as we move on quickly. So all electrolytes contain ions, please. Okay. It is useful in this context to remember that metals form positive ions that are called cations, as I just said, whereas non-metals usually form negative ions that are called anions, please. All right. And also that the number of charges carried by an ion is the same as the valency of the atom or group from which it is derived. The charge carried by an atom is the same as its valency, just like this copper here. It has a charge of +2. Why? Because 2 is the valency of copper. Copper has a valency of 2. So each charge in ionic form will be plus or 2 plus. That is positive plus. Like example, I can say, let's say sodium. When you look at sodium, sodium will lose an electron, and become a what? Sodium ion. Sodium ion. That means one positive, one charge, only one, because it loses only one electron. Why that? Because its valency is what? 1. Valency is 1. So the charge on any ion is the same as the valency of the atom. Of atoms drive. All right. Again, electrolysis still. Hydrogen usually forms positive ions. As we just mentioned, hydrogen will only normally form positive ions in solution, please. Some example of the ions present in common electrolytes are shown below. So that's what you are seeing there on the screen there. We have the NaCl. What are the ions present in sodium chloride? Is in sodium ion and chlorine ion. Sodium ion and chlorine ion. The other one is sodium sulfate. And what are the ions present in sodium sulfate? Is sodium ion, which is the metal, and sulfate ion, SO4, 2 negative sulfate ion, present in sodium sulfate. Copper sulfate solution. What are the ions present in copper sulfate solution? Is copper ion and what? Sulfate ion. What are the ions present in lead bromide? PbBr2, lead bromide. Is lead ion, Pb 2 plus, and bromide ion, please. Sulfuric acid. What are the ions present in sulfuric acid? H2SO4. Is hydrogen ion and sulfate ion, please. So remember now, all electrolytes contain ions, please. Take note of that. So all these you see here are all electrolytes, simply because they all contain ions. Note, very important there, I say note. In an electrolyte, the ions are present before the electric current is passed, please. So remember that. It's not the electricity that gives the electrolytes the ions. They are already present in the electrolyte. The electricity just breaks them apart, but the ions are already present in the electrolyte before the electric current is passed into it or through it, please. So take note of that. So example there, a solution of sodium chloride will contain sodium ion, chlorine ion, hydrogen ion, and hydroxyl ions. If this particular solution is electrolyzed, what happens? The positive ions that are called cations will migrate to the negative electrode. This is called the cathode. While the negative ions that are called anions will migrate to the positive electrode, which is called the anode. Now, by looking at this diagram here, that is showing you there, most often, all positive ions are attracted to the negative terminal or negative electrode, which is called the cathode. So when you look at this diagram here, all those in black here are positive ions. You are seeing them positive. And look at the arrow. That means they have been migrating towards what? This electrode, which is the cathode, the negative electrode. So all positive ions migrate to the negative electrode, which is called the cathode. And the negative electrode ions will migrate to where? To the positive electrode, which is the anode. So you are seeing these greens here are negative ions. You can see the arrow pointing towards the positive electrode, which is the anode. So it means these ions are migrating to the positive electrode, which is called the, please, in the electrolysis of an electrolyte, the positive ions migrate to the negative electrode, the cathode. The negative ions migrate to the positive electrode, the anode. Don't forget that, please. Once arriving at the electrodes, the ions are discharged. Look at that word there again. Once arriving at the electrode, the ions are discharged. What do we mean by that? That is, they become neutral atoms again. Just as we mentioned for copper there, when copper form ion, example there, copper ion, sorry, let me put it this way. Copper atom will lose 2 electrons to become what? Copper ion. So when this copper ion is discharged, what does that mean? It will return back to what? The normal copper atom. This is copper atom. And this is the ion. So when we say this copper ion is discharged, it means it returns back to the neutral atom. How does it do that? It has to gain back another 2 electrons that it lost. So here, this copper ion, we now will combine with 2 electrons, or we take 2 electrons from the electrode, and then will become a what? A copper atom. Now this is a copper. This is a copper atom. That means it's been discharged by returning back to the neutral atom. So this is what happens to any ion in the electrolysis of a solution, please. When the ions reach the electrodes, what happens? They are discharged. They return back to their neutral atom again. That's what I mean by discharge there. You see this process, how it happens as we move on, please. So let's go. So certain rules govern which ion will be discharged first if more than one kind of the ion is present. Certain rules govern which ion will be discharged first if more than one kind of ion is present. Now, at the electrodes, when the electrodes and the ions migrate to the electrodes, most often there are more than one ion in the solution. So the ion discharge depends on some certain factors. The ion that will be discharged first. So we are coming to look at that now. That we call factors affecting the discharge of ions. We also call this as what? Preferential discharge of ions. Preferential discharge of ions. That's to say which ion should be discharged in a solution during electrolysis first. All right. So these are some of those factors that will determine that. One is the position of the ion in the series. The position of the ion in the series. The ion which is lowest in the series is discharged first. And what do we mean by that series first? In other words, we call it electrochemical series, or we call it the reactivity series. It's just a table that shows the degrees in order of reactivity of metals. Here, I show you that on this piece of paper. I will show you that here, maybe. So this is showing you what? The activity of metals. It is called the reactivity or electrochemical series. It lists you the metals in degrees in order of how they will react with certain substances like air, or like with metals, or like acids rather, how they react. So the most reactive metal is potassium. It's the most reactive metal, followed by sodium, followed by calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen. It's not a metal though, it's a non-metal, but we put it as part in the electrochemical series as well. Sometimes it can behave like a metal, please. All right. Copper, silver, and finally you have gold, please. It's the last in the reactivity series. The most reactive is potassium, and the least reactive is gold. This is what is called the electrochemical series of metals, or we call it reactivity series of metals. So during electrolysis now, what happened? The ion, which is lowest in this series, will be discharged first. Like for example, in a solution where you have, like, let me say, sodium and, let me say, hydrogen. Which of these will be discharged first in their electrolytic solution? Which one? The hydrogen will be discharged first. Why? Because it is lowest in the series than sodium. If we have magnesium and another ion in the solution, let's say magnesium and iron, which one is going to be discharged first? The iron is going to be discharged first in preference to the magnesium because iron is lower in the series than magnesium. So it will be discharged in preference to the magnesium. That's what we mean by that point there, the position of the iron in the series. The iron which is lowest in the series is discharged first. Please. So that's showing you there. The cations are the metals, the anions are the non-metallic ions. So the cations, they are potassium ion, sodium ion, calcium, going to the last, gold ion. The anions are the non-metallic ions. You have a sulfate ion, you have the nitrate ion, you have the chloride ion, we have the bromide ion, the iodide ion, and the hydroxyl ion, please. So that shows you the list of the reactivity series. Now, when a cation is discharged, electrons are accepted by the cation. But most reactive metals at the top of the series form ions most readily because the electronic configuration of the ion is more stable than that of the atom. This is explaining why ions lower in the series are discharged first instead of the ions higher in the series. This has been explained here. Now, hence the ion is reluctant to accept electrons and reform an atom, and therefore remains in solution in preference to the discharge of an ion lower in the series. So that explains to you why atoms or ions lower in the series are discharged first in preference to the ions higher in the series. So the second factor that affects the discharge of ions in an electrolyte or during electrolysis is what? The concentration of the ions, the amount of ions present in the electrolyte or in the solution, concentration of ions. If one ion has a much greater concentration than the others, despite its position in the series, it may be preferentially discharged. Concentration also is important here in terms of discharge of ions. If one ion has a much greater concentration than the others, despite its position in the series, it may be preferentially discharged. We give an example there. Example, electrolysis of concentrated sodium chloride solution yields chlorine at the anode, whereas dilute sodium chloride yields oxygen. That is, hydroxyl ions are only preferentially discharged when chlorine ions are at low concentration. Look at the concentration of sodium chloride. What was discharged? It's chlorine. Even though hydroxide ion was there, but the chlorine was discharged. It means the chlorine was in high concentration in the solution than the hydroxyl ion. This is why the chlorine was discharged instead of the hydroxyl ion. But now in the dilute form, dilute sodium chloride, what happened? The oxygen was discharged instead of the chloride ions, please, because the solution is dilute. There is not much concentration of chloride ions there, please. Okay. Now, the third factor that affects the discharge of ions in the electrolysis of electrolytes is what? The type of electrode. There are different types of electrodes. So the type of electrode also affects the discharge of ions in the electrolyte during electrolysis. Now we say inner electrodes. What are inner electrodes? These are electrodes that are not reactive. That means they don't easily combine with acids and they don't react with the walls of the glass container that they are put in. So therefore they are inner, they are not reactive. So inner electrodes, example platinum and copper, do not affect the choice of ion for discharge, but other electrodes may do so. So that explains to you the type of electrodes also affects the discharge of ions, please. Platinum and copper do not affect the choice of an ion for discharge, but other electrodes may do. Now let's look at uses of electrolysis, uses of electrolysis rather. Uses of electrolysis. Why is electrolysis an important process? Electrolysis can be applied in the following processes. One is extracting metals, metal ores from the ground. They are in pure form. To extract them, they are mostly combined with other elements. To extract the pure ion, you have to do what is called electrolysis, like example, aluminium. If you want to extract aluminium from the ground, to separate it from the other impurities, you have to do what is called electrolysis. 2, purifying metals. Electrolysis is used in purifying metals, please. 3 is used in electroplating metals. That is applying a layer of zinc on another piece of metal. 4, ionizing aluminium, please. That's also another importance of electrolysis, ionizing aluminium. So take note of those uses of electrolysis. You can be asked this in your assessments or thesis. All right. So before we leave, now that will be the end of our lesson, but before we go, I'll give you an assignment to go home with. This one is a classwork, but we don't have time to do that. Now let me give you the homework, or you go home and do this. On the next lesson, we discuss it together. It says briefly explain each of the following terms there. A, an ion rather. B, a cation. C, an anion. Explain them briefly. Number 2, what do we mean by the electrochemical series? Explain the term electrochemical series. So that will bring us to the end of our lesson today on electrolysis. And I thank you all for your kind attention, please. All right, till we meet again another time.
Have your say.
Fellow Gambians, my government has approved a $500 million emergency fund, which